All right, so it seems that a number of people have had some troubles on your assignment for problem 16. There are some notations to get used to and some commands to get used to in R. So if you are trying to use the Z table, that's probably why you are having issues here. You're not getting enough digits of precision. So just going through some of this notation. P stands for the probability, and here the capital Z is talking about the standard normal distribution. This is a bell shape where the middle is 0 and the spread is 1. The standard deviation is 1. And so here, this notation of P, where capital Z, which is the standard normal distribution, is less than or equal to some value, such that the area that is on, as you can see here, the less than side, the left side, is some number. So here, if my number was 0.81 or if my number was just x, then you're talking about this bell shape such that you have some value, and on the left of it, you have that amount of area. When you have the area and you are looking for the value, in R, the command to type is qnorm of this area, and it will give you the value. Make sure that you are giving R the area on the left. So for my particular example, I guess it would be qnorm of 0.81, and I get the corresponding value. Should I want more digits, then I can use the command option and then do digits, and I can change the number of digits that R pops out for me to be more. In this case, I seem to be getting the same number. I don't know why that is. I keep on getting the same number of digits. Perhaps that is all of the digits that it gives, and then it's just zeros after that. I don't know. I should technically be getting more digits than that. However, the amount of digits that it has given should suffice. Continuing on with this question. Again, problem B is very similar to problem A. I suggest drawing pictures. The only difference is here for my A, I had a large amount of area on the left, and here for my B, I've got a smaller amount of area on the left. However, to solve it is a similar idea. There's a small slight difference in part C, and you can see that the difference is instead of the less than or equal to sign, I have the greater than or equal to sign. This is talking about the area on the right. Okay, so here, if I'm given the area on the right, for example, I have 30% of the area on the right. That means I must have 70% of the area, or 1 minus the amount of area here on the left. So again, I am still having an area and trying to find a value. So I'm still going to use the qnorm command, but instead of giving it the area on the right, I want to give it the area on the left, or the complement of the area on the right, which would be the area on the left. So here I did qnorm of 1 minus x. So I could say qnorm of 0.7 or 1 minus 0.3. Finally, part D puts together a little bit of this notation. So here I've got the standard normal distribution here, I've drawn it here, such that in between some value called z sub 0 or z naught and some other value, which happens for me to be 0.91, or here's just some other value. So here, in between this 0.91 and some value I don't know, then I have some amount of area given. So here, in this case, between z naught and 0.91, I have 66.94% of the area. What I really want to do is find this value here. I'm going to have to do this in a two-step process. So seeing as I do know what this value is, which happens to be 0.91, I can originally just get the cumulative area. So that is all of the area on the left by, instead of using the qnorm command, qnorm is when I have the area and I want the value, but here I have the value and I want the area. So instead of qnorm, I will use the pnorm command. So I can say pnorm of this value, in my case, which is 0.91, and that will give me all of the area on the left of the value 0.91. Then, so this value right here, I got by saying pnorm of this value. Then I can simply take this cumulative area that I will have gotten from the computer. Let's just see what it'll look like. That would be pnorm of 0.91. Okay, so in my case, that's that amount of area. What I'm saying is on this left side of this x is about 82-ish%, but I wouldn't just want to round. I would use all of the digits. And then here, the area I know is in between these two values was, here, let me just copy paste this, copy and paste it. I know that the area in between the two values here is actually more like 6694. So if I take this cumulative area and I subtract off this middle area, I will be left with just this little tail area. Okay, so in this case, this little tail area must be the cumulative area minus the area that I was given originally in the question. At this point, I now have an area given to me, and I can, in fact, find out what the value is by using, again, the qnorm command of here, the difference between the cumulative area and the area that I was given, finally giving me the value for the z that I'm looking for.